So let's see here. What's the next subject? So the last thing I want to talk about here, getting into more of these properties of light. And this is a really cool one, the dual nature of light. So this is something that has been mind-boggling for physicists and chemists alike for 100 years. So light, as it turns out, is a particle and a wave. Simultaneously, it can exist as a particle and a wave. And there's really good examples of both. So here's the famous Young's double slit experiment. And I'm going to show you a video of this soon. But the way the double slit experiment works is from the following. So we shine a beam of light. So this is showing you light as a photon. So whenever you see like a little particle, you know, we think of it as a photon. However, in Young's double slit experiment, he demonstrated that that photon really acts like a wave. Okay. So as it passes through a slit, which is just a narrow opening, light does what's called diffraction. So we talked about refraction, but now this principle of light spreading out as it goes through a narrow opening is called diffraction. And so if what you would observe here is, so suppose we have a beam of light coming through so we can see it diffracting. If we just had one slit opened, we would just observe a whole like beam of light, like a whole spread out mess of light, okay? And so this is showing you if you have like, you know, the right slit open, you get this thing. If you have the left slit open, you get the same thing. But now if both slits are open simultaneously, then you start to see the manifestation of light as a wave. In other words, what happens is it interferes with itself. Just like I showed you, let's back all the way up, just like I showed you in this slide, when the light is now forced to pass through two openings, you can get constructive and destructive, simultaneous constructive and destructive interference, where you have really bright spots and a bright spot, and let's say no spots at all, okay? So I'm going to show you, instead of these like pictures here, I'm going to show you an actual video of this. This is from the YouTubes, so this is pretty cool. So let's watch this.
For you to do this experiment in pairs. So what does it involve? It involves this, which is a spirit level that's got a laser in it. So if I point that at the wall there, hopefully you can see it's a red laser. It's a nice low power laser that's going to be safe for us to use. Young did this hundreds of years ago, so he didn't have lasers, but they make our life easier, as you will see. We've got this thing here, which is a collection of double slits. So if you look really closely, you can probably see 4 slits in this slide. If I hold it up to maybe a white background, you see more clearly. Each of those things that you can see there, oh no, that's lovely, that's focused really nicely. So you can see that each of those things that look like one slit is actually a pair of slits. And the ones on the right are quite far apart, and the ones on the left are really close together. So these are double slits. What happens when the light passes through these two slits is that it spreads out. So when light passes through a narrow gap, it spreads out, it diffracts. And then the light coming from each of
Diffraction.
those slits can interfere. So I'm going to shine the laser light through. I'm going to use the leftmost pair of slits because that's going to work best. So I'm going to shine this laser through a double slit, and then all the way over there, I'm not sure if you can see it, is a screen. It's a long way away, and you'll find out why that is shortly. So, here we go. I'm going to turn the lights off.
I think this guy's like a high school physics teacher in England.
And I'm going to direct the laser through 2 of the slits. So the laser light is going through a double slit, 2 slits very close to each other. All the way down there on the screen, you might just see some red. Now, actually, let me show you what it looks like without the double slit. Without the double slit, it looks like a dot.
Just a beam, a bright spot of light,
Okay.
which is kind of what this picture is showing you here.
Now, I put a double slit in the way. So the laser light is passing through both of those slits, it's spreading out, it's diffracting. But when it gets over here, you get...
Look at that. That's awesome. There is the interference pattern, right? So you can see where it's really bright, that's where there's maximum constructive interference. And where it's really dark, those dark spots in between are the destructive interference, which is also really cool. So I'm going to put that away now here. So that's light acting as a wave. But what about light acting as a particle? Well, once again, kind of reiterating, showing you what that Young's double slit experiment showed you. If we're thinking of light as a photon, so photon is like a particle, okay? Like a little ball, like a little billiard ball that can fly off ballistically, okay? So what you would expect, this is what you would expect if light is a particle. All of those particles would just funnel through those two narrow slits, right? And you'd see like a whole bunch happening here and a whole bunch happening there, okay? But that doesn't really explain what's actually going on. What's actually going on is that they're interfering with each other, okay? So a really good example of light acting as a particle is through a laser light show, believe it or not, okay? So you see all of these lasers here, and we can see a nice straight beam trajectory. I mean, have you ever wondered why you don't observe this with your laser pointer? Like, I don't have a laser pointer right now, but if I shot a laser pointer, I can see it reflecting off of the surface wherever it's pointed, but I can't see the actual laser line. So what they do in these laser light shows is they put a bunch of aerosols or particles or like smoke right in the air. And so now you have all of these smoke particles in the air, okay, which I'll draw as dots, all right? Okay. And as a beam of light comes through, let's change my color. So now let's say here is my photons, and I'm just going to draw them as one single line. Like suppose I've got like a laser pointer, you know, shooting my photons out, okay? So they're all coming out ballistically, and now when one of those hits one of those particles, it goes scattering off that way. And when another hits another one of these particles, it goes scattering off this way. And so now all of these photons, this probably looks like a mess, right? But all of these photons are scattering off in all directions. They're all being spread out in every direction. And now for you, random person in the audience here at this laser light show, you're going to see that beam being scattered off one of those smoke particles that's in the air, okay? So this is not an interference thing. This is just a one particle colliding with another particle and going off in another direction, all right? Which is pretty cool stuff. So again, the dual nature of light, light acts like a wave, but it's also like a particle. So that photoelectric effect idea that I showed you, that's kind of light acting like a particle. The Young's double slit experiment and these interference patterns, that's light acting as a wave. Laser light shows where you actually see that beam of light because it's being scattered off of some like smoke particle or some aerosol, that's light acting as a particle. So we kind of have to accept that the current state of physics on light is that it's both. It's both a wave and a particle. And that's a pretty good place to stop, folks. So I'll pick up on the hydrogen spectrum and the Bohr model in the next lecture. All right, hasta.